Okay, so let's start. This is my milestone 3, and my topic is making a tiled version of a different renderer. What I have done in this milestone is the first thing is I fixed the skeleton mesh in the Prime Engine. Like in the previous versions, the skeleton mesh was broken because the different renderer, but I fixed it and I create a new thing for the milestone 3. Let's have a look. It goes, it's not very smoothly, but it works, yes. And I feel like it works well. And everything on the thing is working correctly. And if I use tab, which I have a debug system, uh, it goes to this. This is a tiled show of everything because you can see there are some like red thing around here. Like some blocks are red, some blocks are black. They have no max because like this red part is like the tiled with point light or other kind of lights. They have a light source, uh, like facts on that tiled. There are a lot of flickering in the screen because I passed the default like debug information using a texture, which is not very reasonable because sometimes the memory will flush and the texture will flickering and the show could go wrong. But yeah, I think that's a problem, but it's not a very big issue because it's only used for debug. And this is like a texture, one of the G buffers you can see in the like debug scene. Uh, this is a color like G buffer, and also we have a normal G buffer. You can use tab to switch between like different buffers and different informations. And also we have a position G buffer with just a like a button you can change. And this is like the tile. As you can see, the tile is moving. The red part is like the direct light is showing which part has the direct light shaders. You can see that the colors are different, some kind of different. I will explain why that happens, but this is like the tile mask of the deferred render system. And you can go back to the main thing, which is pretty good. Okay, and I will show you the implementation of all this. First, I fixed the like skeleton system, but that's not the big thing. So we just start from the tiled version because the tiled system originally needs the compute shader, but it's not happening because we're using CGGL, which is a deprecated like APIs for OpenGL. It doesn't support the compute shaders, so we use an alternative idea, which is just create an eight like multiply eights like eight textures to store the masking that. And you can see I created from the here it's like a created deferred light mask texture, which is a texture. It's basically just a texture with RGB 8. So this is like 8 bits data for every pixel, and we only have like 8, like the width is 8 and height is 8. So it's just a very small textures, and we will pass the textures into the like we have a root sync node which keeps every light here, so the light information is in the root sync node. And then we do a bit mask. This is this mask is like uh responsible for the passing the informations to the lights in the shaders. As you can see, we can grab the things from the shaders. You can see that more clear. which is this file. Uh, as you can see, we have a very clear structure of the bit mask. It's just we passed the base mask in this G light mask, and the G light mask will transform into U ink, which is a ink mask, and then every bit in this mask is like related to one of the like light here. So, in other words, uh, the bit mask created in the CPU, they just told every tiles which like what which lights you're using in this tile. See, they don't bother to calculate other lights. Originally, it can pass like 32 because only use one of the colors, which is 8 bits. But you can create like RGB. If you're using RGBA8, it means 32 bits of information. You can use 32 lights. But right now, we only have 8 lights in the shaders. It's just pass that data into the GPU by that structure. So I haven't changed it, but I think 8 is quite enough. So we have just 8 bits. You can see here, like every light is detected here by the like sub frustum. I also created a bunch of sub. You can see that this structure is just the store all the subs frustum from the main frustum, and the have every like little tiled version of like calling things, and they have planes do the detections to the light, and then if the light is hit, they will do this bit mask. So like the bit mask will blend everything into this 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 bit mask. But this bit mask is only used in the red channel. As you can see here, actually we only use like this plus zeros, but we can this means, but this has the 3 channels with the RGB. We only use the red channel. So you can only see the difference in the red. You can see like we have a debug texture things in that shows. Let me show you again. So here, chain, 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 chain. Okay. So you can see every part is either black or it's red, because the red is like this color. This red color is related to this mask. It's just this mask. Actually, it's just this mask. So you can only see red colors here because the bits is only uses the red channels. But of course, if you have more lights, you can add more to that. It's like you can store more information in the textures and create maps, bitmaps more. Like you can enlarge it or store more information on that. So yeah, I think this is the basic functions, and it do cost uh, like it, I believe it optimizes the performance, especially when the like the render card light is a very complicated very complicated method. But for now it's not, but because this engine is very easy, like the structure is very clear, and there are not like all kinds of materials here. But if there are a lot of lights and only few lights are in that area, the tile thing is definitely worth a try. So yeah, and this is the debug information from the shaders. We just use another bit mask to do that. It's not very good. It's not very ideal, but I feel like if it's big debug, it's just it works. It works. So yeah, I believe that's all I have done, and I also created several other shaders like gray shaders, backup shaders, and like I also changed like detail skins to fix the skeleton mesh in the like the animations in a different renderer. You have to submit them to the GPU pipeline. Yeah, I think that's all, and it's not the best way to do this because we don't have like modern OpenGL APIs use like computer shaders, but I think the bitmask is kind of a compromise, or it works. So it doesn't change the fact that we're still using one shaders. We don't like split the shaders into several into several types to optimize it. But I think I do the best to under this structure. So yeah, it looks cool, and I think that's all.